Hi guys, this is Anastasio G. Pantaleon Jr. and welcome to my YouTube channel. And in this video, we will be learning about the non-exact differential equation. So if a differential equation of the form m to the function of x and y dx plus n to the function of x and y dy is equals to 0 is not exact as written, then there exists a function mu to the function of x and y such that the equivalent equation obtaining by multiplying both sides of the equation mu by mu is equals to mu x dx plus mu n dn is equals to 0 is exact. So a function mu is called an integrating factor of the original equation and is guaranteed to exist if the given differential equation actually has a solution. Integrating factor turns non-exact into exact ones. So there are two cases that needs to be tried in order to find the solution and makes the differential equation exact. Uh, Case 1, consider the differential equation m dx plus n dy. This is all of the functions of x and y. Okay, this is both to the function of x and y is equals to 0. If this equation is not exact, then m derived to the y, remember this m was derived to the x, will not be equal to the n derived to the x. Also, we take note that n has been derived from dy. So that is uh, m derived to the y minus n derived to the x is not equal to 0. Or we may say that it is not exact or it is not equal when we transpose this n to the x to this side. However, we have m derived to the y minus n derived to the x, and when we divide that by n, the original n is a function of x only. Let it be denoted by this symbol. Then mu to the function of x is equals to e integral of epsilon x dx will be the integrating factor of the given differential equation. So we have an example is this one, 3xy minus y squared dx plus x divided by x minus y dy is equals to 0. So we denote this one as m and this one as n. And take note, we don't know yet if it is case 1 and case 2. But the main thing here is uh, to test for exactness first. Okay, so m partial derivative of m to the y is equals to 3x minus 2y. Then partial derivative n to the x is equals to x minus y. Take note, this is not exact differential equation. So we need to find the epsilon to the function of x, okay, which is equal to uh, m partial derivative of y, which is this one here, and n to the partial derivative of x, this one here, overall n is 1. Okay, so therefore your equation becomes 3x minus 2y minus 2x plus y, okay, all over x minus y. This becomes negative y, okay, x minus y over x minus y. Okay. Therefore, your epsilon to the function of x is 1 over x. Those we will find your integrating factor of the function of x as e equal to the e to the integral of dx for x. Okay, we take note, uh, go back to the concept that it should be simple x here that was going to left be left to remain. If both x and y exist in this area, it is hard for you to derive that. Okay, so take note. Case one is possible, so we have ln x is equals to x. So this x is your integrating factor, and you have to multiply that with be distributed. So therefore, your your equation now is dx squared y minus x y squared, okay, x plus x cubed minus x squared y dy plus the 0. Okay, we take note that this is in the form of 2 mx plus 2 ny, okay, as we discussed earlier. So we test this for exactness. Okay, so this one is d mu m y is equals to x squared minus 2x y. The other hand, we have d mu n to the x is equals to 3x squared minus 2xy. Voila, it's magic. We are exact now. Right? So in this case, uh, to find the solution f x y is equals to c, we have to first uh, integrate mu m dx, of course, plus g of function of g of y. Okay, so this becomes integral of dx squared minus dx squared y. Okay, sorry, erase that. X squared y minus xy squared, okay, x. So you have uh the of that. So uh, x cubed y. This one is integral of, so we have x squared over 2, okay, x squared y squared over 2, okay, plus g of y. The other hand, we need also to integrate mu and y. This is just equals to x cubed, integral of x cubed, okay, clarify that. So integral of x cubed minus x squared y plus f of x. Okay, so this becomes integral of myself half, so x cubed y, so that. Then the other one is we have negative, say, x squared y squared over 2. Okay, as function of fx. We take note they are all the same. Okay, so therefore your function of x y is equal to x cubed y minus x squared y squared over 2 is equal to c. Okay, now for non-exact differential equation, in consideration case 2, where uh, the it's a function of y alone, where your mu, your example mu, y dy. Okay, find that. So instead of n here, we have a negative m coming from this one. Okay, just in case that case one would not give a simpler solution, which is a function of x alone, but you have x and y over both. So you consider solving the equation to case 2, which try to justify if it is a function of y only. Okay, now we have your equation here, 6xy dx plus 4y plus 9x squared y. So first, label this one as m because it has dx in it. You label this one as n because it has dy in it. So, staying for exactness, we have partial derivative m the y, we have 6x. On the other hand, partial derivative m to the x is equal to 18x. So therefore, this is not an exact differential equation. So first, you have to uh, try to solve that using case 1. Okay, case 1, a trial and error, wherein your uh, u, or I mean your epsilon, I guess. I think your epsilon. Okay, remember your epsilon, the x is equal to m y and x, and we take note. This is, we write it here, equal, say your my is 6x, your nx is 18x, your n is 4y plus 9x squared, which is negative 12x 4y plus 9x squared. Now, as we can see, this is very hard to solve as an integrating factor because it has y in it. Those case 1 is not possible. So we try case 2. So case 2, we have your symbol like this. Okay, the y is equal to my minus nx function over the negative m. and therefore we have your negative 12x, and your m here is 6xy, so you have negative 6xy. Self, we have negative, the negative we have positive, so we have 2 over y. Therefore, your integrating the function of y is equal to e integral. We have to take out the 2 from the integral part, so we have y over y. So in this case, we have e 2 ln y, which is equals to e ln y squared, which is equals to y squared. Now, this integrating factor is then multiplied on both sides of the equation. So multiply this one, you multiply in this side of the equation, all of this. And we have the final form, okay, the same in the form of u m dx plus mu n dy is equals to 0. So we multiply that. So we have the mu m now becomes 6xy cubed x, okay, x1 plus, okay, we have 4y cubed plus 9x squared y squared y is equals to 0. Now, testing again for exactness, we have the partial derivative of u m to the y is equals to 18x y squared. On the other hand, the partial derivative of uh, mu n to the x is equals to the same 18x y squared. So now they are exact differential equation. So therefore, we find the solution for the problem. We have f to the function of x, y is equals to c, which can be found by first integrating mu m dx plus g of y. Okay, those integrating 6x y cubed x plus g of y will give you x dx squared y cubed plus g of y. Okay, the other side we have 2 integral of n dy plus f of x is equal to integral of 4y cubed plus 9x squared y squared. Okay, think that squared dy is just equal to, say, this one. So we have y to the fourth plus, I think this is 3x squared y cubed, okay, plus f of x. So therefore, your equation is that you have to identify which has the same content, both these integrals. So first, your function f of x, f to the function of xy is just equal to 3x squared y cubed and 1. The remaining one we have y to the fourth, which is equals to c. Now this is your final general solution. So I hope you learned and thank you for listening.